Breaking it down a little further, looking at the outside layer. The outer layer of the eye, there's two parts. The cornea, that's on the front, that covers the front of your eye. If you've scratched your eye, you've scratched your cornea. And then the sclera, like I said, is the white portion of your eye, but it covers the entire eye, not just the front. Fibrous, it's tough, it's thick, it prevents things from puncturing your eye. The sclera is made mostly of collagen, and like I said, it's protection, it's thick, and that's where the muscles for eye movement actually attach. The optic nerve is considered part of the outside layer. It is at the back, so the optic nerve and blood vessels come into the sclera at the back of the eye. And where these blood vessels are at, sometimes if someone has high cholesterol, your optometrist can sometimes tell that, because if those blood vessels at the back of your eye have extra fat on it, a lot of times that can signal that you may have high cholesterol. So a little side note. So outside, sclera, cornea, and then the optic nerve. Middle layer is vascular. So that is where your blood vessels, your nourishment comes from. And it includes the choroid coat, which is the middle layer for most of the eye, ciliary body, and then the iris, the colored part of the eye. The choroid coat is vascular, and it's dark pigment. It's going to have a dark color to it. It nourishes the other tissues, that's why it's vascular. And then it also keeps the inside of the eye dark, so that when light does come in, that light is not distracted by other light that's already in the eye. The ciliary body forms a ring around the front of the eye, and it contains ciliary muscles and those suspensory ligaments. And what they do is they attach to your lens. I pointed that out on the diagram last time. And it also changes the shape of your lens, so that when I'm looking at something close, my lens is going to change shape compared to when I'm looking at something far away. As people age and get bifocals, that typically deals with this process not working as well as it did when they were younger. So now I'm looking at the front. So basically I've cut through the eye. So here's your lens, which is like a little round ball. So if you've dissected an eye, a frog, and you've taken the lens out, it's basically like a little round, thick ball. The suspensory ligaments then are going to attach to it and cause it to enlarge and shrink a little bit. And then this is the ciliary process, retina, choroid, sclera, the three layers. The ability of the lens to change shape, like we were talking about, that ability is called accommodation. So when the ciliary muscles relax, the ligaments are going to pull outward, causing the lens to flatten, and then you can see distant objects. So like when you're reading a book, and then you look out the window, your lens changes shape. It's going to flatten when you're looking at things far away. It's going to shorten when you're looking at something that's closer. And like I said, as you age, that process doesn't typically work as well. A lot of times between 40 and 50 years old, a lot of people will have to get bifocals. Even if they had good vision before that, they may need help reading things that are close. And this diagram just shows, here's when my lens is a little bit flatter, and there's when it's a little bit shorter. So here I'm looking at something close, here I'm looking at something far away. The iris is the thin, pigmented, which means colored. It's a colored, smooth muscle, and it adjusts the amount of light that goes through the pupil. Iris has a circular set and a radial set of muscle fibers. Dim light, so darker places, are going to stimulate the radial muscles. Your pupil dilates. It opens. If it's dark, Your pupil wants to let in as much light as it possibly can so that you can pick up and see some things. Bright light is going to cause the circular muscles to close and your pupil to get smaller so that it does not let in as much light. And there you can just see it shows the different sizes of the pupil. Top is in a dark spot, your pupil is big. Bottom is in bright light. Okay, if I'm looking at the anterior chamber, so this is in front of the lens. It's between the cornea and the iris. The posterior chamber is between the iris and the lens, and that whole thing makes up the anterior cavity. Front part of your eye, aqueous humor, watery. When we dissect the eye, you'll be able to see. Aqueous humor circulates from one chamber to the other, so the anterior chamber and posterior chamber. It can leave the anterior cavity through your sclera, and then it can actually end up in your blood vessels. Glaucoma, if you have a relative, and typically this is an aging disparament also. Glaucoma is a buildup of that aqueous humor, and that increases the pressure on the eye. And if that pressure gets too high, it can lead to blindness. So glaucoma is an increased pressure in your eye. Cataracts are when you have clouding of the lens. That's another problem that can happen with eyes as they get older. Moving to the inside layer, the inner layer is the retina. It has all your photoreceptors, so that's where light is actually received. The inner tunic of the retina is going to be on the back side where most of the light hits the back part of the eye. In the center, I pointed out on that diagram also, is the fovea centralis, and like I said, that's where you want light to focus to get your sharpest vision. So those of you that do not have glasses, your light, your images are focused exactly where they should be. This part I'm not concerned with. The only thing I want to point out is in your retina, there are rods that pick up black and white. There are cones that pick up colors. So rods only see black and white. Cones pick up colors. And I will not have either of those pictures on your test. The optic disc is where the nerve fibers leave the eye, so it's right in front of your optic nerve. The optic disc is also called your blind spot. So there's a spot in front of your optic nerve where if the image is put right there, you're actually going to lose vision of something for a short period of time. Posterior cavity, vitreous humor, much thicker. Collagenous fibers, vitreous body. It supports the shape of the eye and makes sure that it stays circular. So the pressure of that vitreous humor helps keep the eyeball nice and round. Also, the vitreous humor, if you ever have little floaters, like you're looking outside and you'll see like a little black spot kind of float, that actually is a little bit of crystals that form in your vitreous humor. Very normal. Some have more than others, but that's where those little floaters come from. A lot of times on a sunny, snowy day, you'll notice a few of those. This diagram, not as concerned about either, other than this is a very nice picture that shows what an optometrist might actually look at. So here you can see where those blood vessels and the optic nerve are going to enter right there at the back of the eye. Light refraction. When light enters your eye, it's refracted, which simply means it is bent. Both the cornea and the lens bend light waves, and basically they're bent differently because they go through the aqueous humor, which is thin. They go through the vitreous humor, which is thick. So they bend light differently. If the shape of the eye is normal, light waves are going to focus on that fovea centralis inverted. So inside your eye, vision is upside down. It is flipped when you interpret it in your brain. So what happens, here's an example of refraction, and if you have glasses, this is how they work. Some glasses have a convex surface where they curve on the outside, and what happens when it enters, it's going to bend the light inward. Converging means to bring together. So it's going to take these light waves and bend them inward. So convex, converge, brings light inward. Concave does the opposite. Inside your retina, there's two types of neurons, your rods and cones. I pointed those out. Rods are longer, your cones are more rounded or blunt shaped. Rods are very sensitive to light, function in dim light. They work very well. They produce black and white images, and their images are not as precise as a cone is. So main thing I want you to know, rods produce black and white, and they are very sensitive to light. And there's a picture again where you can see the rods are longer and thinner than a cone. And there's an actual microscope picture. Cones provide the sharpest image, and they are in color. So that's the most sharp image and in color. To see something, you want the image to fall on the fovea centralis, and there are a lot of cones that are abundant in that fovea centralis. And then as you go away from that fovea centralis, there are fewer and fewer cones. And that's not so important. And I will stop there for a short period.